plastics, medicines, and innovations that make life modern come from one place. American Chemistry. AmericanChemistry.com. Essential.
So we're back to talk about carbon. As you learned last time, carbon itself isn't necessarily good or bad. It's all about where it ends up and in what quantities. So if too much of it piles up in the atmosphere, global warming. But what if you happen to be in a situation where too much carbon is in the atmosphere, like the one we're in now? Is there anything we can do about it? Well, one idea is pretty simple. We can capture the carbon and then store it somewhere safe. That's essentially what nature does. Plants performing photosynthesis, the ocean absorbing CO2 out of the atmosphere. It just takes hundreds, if not thousands of years to safely lock that carbon away. We need to recycle the carbon faster. So let's go back to the paper analogy. What if every time I printed out a piece of paper, instead of letting it float around in this mess, I stacked it neatly? Well, the fossil fuel version of this is called carbon capture. We gather up the excess CO2 every time we burn some of the oily black stuff, and we make it easy to handle. Now everything's in nice, neat stacks. But it's not like I've stopped printing out paper. Now it just goes into these nice, neat stacks. It's really only solved half my problem. What I need is a permanent solution for these neat stacks of paper. Something that will keep them from polluting my office. We have a similar thing with carbon. It's called carbon storage. Deep beneath the earth or deep beneath the sea. Put it away, lock it up. Keep in mind that this carbon capture and storage doesn't actually do anything about the CO2 that's already out there in the atmosphere. It just keeps the problem from getting any worse. Of course, the best solution is to burn less fossil fuel, but that's not very realistic. So carbon capture and storage might represent our only realistic option for getting around the carbon problem. That wasn't so hard, was it?